Assalamualaikum warahmatullahi wabarakatuh. My name is Fakim Nazhan. My ID number is FB18076.
Assalamualaikum, I'm Nur Amira binti Abdul Hafiz.
Hi, I'm Goiming.
Assalamualaikum and very good evening. My name is Siti Nurabaya and I'm the leader of Sketch and Design.
Good day, sir. I'm the leader of construction design. I'm Eng Sing Hui.
Good morning to Dr. Abdul Aziz. My name is Wong Xiaoqing. I will present.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Akmal bin Zulkifli. My ID number is FB18067.
Warahmatullahi wabarakatuh. My name is Nur Syahidah Zahra Teman Family. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tirena Syira binti Muhazikri.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Syaira binti Azlan, FB 17049.
Assalamualaikum and good day, sir. My name is Ahmad Arham bin Ali. I'm from section 2. My ID number is FB17136.
Warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Fauzi and my ID is HA17091.
Assalamualaikum. My name is Nuriana Quraisha binti Abdul Manan. So here.
Good afternoon, sir. My name is Juti Hao.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Mahdi Noh Hijazi.
Okay, Assalamualaikum and good day to Prof. Abdul Aziz. Today,
Assalamualaikum and very good evening, Prof. My name is Mizaliana Taha binti Sulaiman.
Assalamualaikum warahmatullahi wabarakatuh, Prof. My name is Muhammad Ihsan. My ID is A17061.
Hello. Assalamualaikum. My name Abdul Muhammad bin Muhammad Yusuf. For my ID number FB17089.
Assalamualaikum warahmatullahi wabarakatuh. I'm Raudatul Syakina binti Rosti, FB17056.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aida Sofia binti Asabi, FE17114.
Assalamualaikum warahmatullahi wabarakatuh to my Prof. Abdul Aziz. Okay.
Very good day, Prof. My name is Nasrul Azimi bin Muhammad, FB18104.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and a very good morning to our Professor Abdul Aziz. Okay, my name is Muhammad Syamuddin bin Abdul Aziz. My metric number FB18088.
Assalamualaikum and hi, my name is Muhammad Hafizi bin Zulkifli.
Assalamualaikum, my name is Muhammad Afiq bin Rusli, FB18089.
Assalamualaikum and good day to our lovely lecturer, Dr. Abdul Aziz. I am from Group Mechatronic and Manufacturing Design. My name is Muhammad Syawir Majhak.
Hi, my name is Muhammad Syariano bin Muhammad.
Very good afternoon. My name is Chong Chen.
Assalamualaikum. Hi, my name is Hanin Farhana binti Jamaluddin. My ID number FA18006.
It's my class project. So how I do in this project, what I do in this project is I lead a team to ensure that everyone understands about this project, what is naturally, about how are we going to do the project successfully. Okay, next, how do I lead them? We make our own group WhatsApps to make sure that everyone can get involved. After that, we selected a task leader for each task to make a simple one-way chain. I also held a Google meeting using a Google Meet to discuss about the task and can start it soon. In between the project, I also help all the groups by giving them idea and also contact to our lecturer about this project and confirm about it and then keep getting updates.
So for this project, I do a Gantt chart, but only for design and planning part. So here our Gantt chart, as you can see, in this part or in this design and planning part, we got 4 steps, which is the first is design the product. Second, select the material. Next, provide a manual. And the lastly is decide the concept of manufacturing and mechatronic that consists in this product. We start it at week 8 after got briefing project from our doctor, and then we done it at week 9. We take almost a week to complete all the steps before giving it to another group, which is a sketch group, to proceed the next step. So that's all from me. Thank you.
And today I'm going to show you that the density of the eggs will change dependent on the temperature. So usually the normal eggs, when you put in a tap water, will sink to the bottom. because the eggs has higher density than the water. But then when you add salts in the tap water until a level that the water is more denser than the eggs, so that the eggs will float to the surface of the tap water or around the middle. So the experiment that I did is I reduced the amount of salted water to the point that the eggs just floating around the middle, so that when I take the boiling eggs, the boiled eggs that is still hot, about 100 degrees Celsius, and when I put to the partially salted water, instead of floating at the middle of the glass, it will float to the top. It is because the temperature increases in the egg will cause the volume of the egg to increase. Increase of volume will reduce the density of the eggs even more. Thank you. Alright, now I'm going to show you whether the eggs density will change when the temperature raises. Hi, I'm Goh Ming. And today I'm going to show you an experiment of the density of the eggs changes with temperature. So here we got normal tap water, and here is the salted tap water. And this normal temperature eggs that haven't been boiled. First I'm going to put it in the normal temperature tap water, and the eggs sink. Now I'm going to put it in salted water. And it floats. I will do it again at the not salted tap water, and it sinks. It shows that the salted water has higher density than the eggs. That's why the eggs is floating in this salted tap water. And now I'm going to reduce the amount of salt in the water to make sure the eggs is about floating in the middle. So I'm going to pour some here. Right. And I'm going to add more normal tap water inside. Still floating. Alright, now the amount of salted content in this tap water had been reduced, so the eggs is just barely float around the middle. This means later if I put a hot boiled eggs inside, it will allow the boiled egg to raise up if the theory about the boiled eggs will have lower density due to the higher temperature in it. Right, so these are boiled eggs. Looks, the egg floats easily to the surface of the partially salted water. Then this is the non-boiled eggs. It floats around the middle. But the boiled eggs floats fully to the surface of the partially salted water. Alright, that's all for today's video. Thanks for watching, and see you guys on next video, probably. Alright, bye.
I will show you what is my work is. So for the assumption, we assume that the egg is in spherical shape and have radius of 2.5 cm. The radius of the egg is very important in designing the whole machine. So for the second assumption, we assume that the thermal properties of the egg and the heat transfer coefficient is constant.
Today I will talk introduction part and engineering assumption part. As we know, the egg contains egg white gels and egg yolk gels at different temperature. So in our project, we design model and set 3 different temperature. That is T1 is 80 degrees Celsius, T2 90 degrees Celsius, T3 is 100 degrees Celsius. So as we know, we can refer table A9 to get the thermal conductivity and diffusivity of the egg. So in engineering assumption, the egg is in spherical with radius 2.5 cm. So the thermal properties of the egg and heat transfer coefficient are constant. Then the Fourier number is greater than 0.2, and that is one term approximate solution are applicable. Thank you, sir.
Presenting for the conceptual design group. I'm responsible for the engineering equation and the working process for our prototype design. We use Biot number equation to obtain A1 and lambda 1 of the sphere, and then by substituting the value of it, we can get the Fourier number, and use the Fourier number and substitute inside the equation 3 to obtain time required for the temperature of egg to reach desired temperature. 3 different temperature, and first we find Biot number, and second from Biot number we use interpolation method, and then we use equation 4.28. After that, we get the value, we put into Fourier number formula, and we get the time 19.7 minutes for first temperature. Second temperature we get 15.6 minutes, and lastly temperature we get 13.5 minutes to cook the egg. That's all for me. Thank you.
Okay, this is the description work. Okay, the part of project that we need to do the advanced fluid dynamic. Okay, our team leader decide to divide 2 parts, calculation and simulation. I and Darina do the simulation part. Okay, before we decide to use the COMSOL, we try to use the CATIA. But the problem is the selected of the material that we select is come out with error. So we try to do and research about the COMSOL, how to use the FEA to get to use the COMSOL. So we try to download and do the simulation design. Okay. Okay, this is the method of the simulation. Thank you.
I would like to present about what I have done for my project half-boiled egg, and I in a group, my subgroup is advanced fluid dynamic, and we need to do a mathematical calculation, and then we need to do the simulation for our project using a software which is COMSOL Multiphysics software. This software will show us how to calculate it, and here in my paper, I show the step how to use the console, multiphysics, and you need to create the flow of heat transfer in the software. And it's not, if you can see from here that I show step by step until you have get the result, and let's see you can compute it. That's all from me. Thank you.
I am from Group 1 for Advanced Fluid Dynamic Pipe. As for my pipe, I have to draw the boiling egg to find the to show the final analysis of the boiling egg. So for this final analysis, I'm using COMSOL software, which is the easier to me compared to CATIA and MATLAB, because I just have to learn from YouTube. Okay, for the boiling egg, the parameters is I'm using the initial value of egg is 8 degrees Celsius, while the external temperature, which is the water temperature, is 70 degrees Celsius. For the density of the egg, I'm using 993.05 kilogram per meter squared, and the specific heat is 4178.5 joule per kilogram, and the diameter of egg is 2.5 centimeter, and the heat transfer coefficient is 1200 watt, and for the external temperature, which is we have to find what time consumed to make the boil until 70 degrees Celsius. The parameters that I take it from the textbook, which is provide in the problem 4.3. So from this software, we can know the movement of the heat transfer move into the egg, through the egg, and we can know the time dependent for the egg to boil until 70 degrees Celsius. Let me show you the movement of the egg. As you can see, the red color is the most heated area, yellow color is the less heated area, and the white color is a non-heated area. Thank you.
Now I'm going to present my task for heat transfer project. My task is doing the animation for flow of heat transfer with 100 degrees Celsius of external temperature, which is boiling water. The initial temperature of egg is 5 degrees Celsius. At the end of the video, I will conclude the data that we use and the animation heat flow of the egg. Thank you, sir.
So we did our first discussion through a Google Meet, and we divided our group task into 4: design, manual, material, and last one, the mechatronic and manufacturing concept. As a group leader, I managed to divide all the job fair and square. So on my part, I did the process of planning design. The spotting that need to be considered the criteria, concept, overall, and handle dimension. Based on the criteria, I have to consider the safety of the product. It also must be lightweight, easy to be handled. Material need to be chosen carefully and can withstand the resistant heat. And as for the shape and the size of the product, it needs to be relevant and easy to be moved. For the concept design, I chose modern and simple design. It must be user friendly, and this product will limit on 3 egg only. In finding a good dimension for overall design, I did my search on all the product that boil egg in the market. For optimal size, 7 by 6 by 6 in inch is the best, as it is easy to move with that size and can be stored easily. I decided that handle design will be 6 long inch, so that's enough to avoid hot water from our hand. So thank you.
And the next is working process of the design. We start by pouring water to the reaching marking point, and then we plug in the cooker and close the lid to insulate heat. Then we push the trigger button to start the boiling. Once the LED light is turned off, which indicates the water is boiled, we insert the egg and trigger the valve. The valve will drain the water. Once the water is drained completely, and we can have a half-boiled egg. Thank you. That is all from me.
I want to present about the concept of manufacturing and mechatronics under the design and planning. The manufacturing process is begins the product design and
I am the one of the member of the conceptual design. In my part, I am doing about the model comparison. In this case, we have two models, model A and model B. We compare it in three sectors, which is heat conduction, heat conversion, and also the cost. We saw that the model B have the heating coil under and around the water container, and is more heat coefficient to conduct the heat from the heating coil to the water container. Besides that, the conversion of the water body is also the better in the model B. And lastly, the cost is the model B is more economic and cheaper than the model A. That's model B will become our design. Thanks.
So for the machine, there are 7 main parts that include the cap opener, body, LED, heating coil, base, and also the egg chamber. Okay, the dimension of each part I have included in here, and the egg chamber have a mark level and also hole for the water drip, and the LED will light up when the temperature of the water inside the egg chamber reach a certain temperature that we have set to 80, 90 and 100 degrees Celsius. Okay, the heating coil, the function of the heating coil is to heat the water at a certain temperature. Thank you.
From Group 1, and I'm part of the conceptual design. Here are the isometric design for our half-boiled egg, and the dimension I've already explained by my other members, and I will explain about the design consideration. Why we choose cylinder type of design like the rest of the group? Why not square? Why not other type of design? The reason is quite simple, since heat transfer is is considered the surface area. More surface area, more heat transfer will occur. Therefore, our design must minimize the surface area that we use in order to prevent heat loss to the surrounding. When we heat, we want the heat to always stay inside of our device and not lost to the surrounding. Okay, that's all from me. Thank you.
I want to present about the project half-boiled egg. The task is sketch of conceptual design. I do the orthographic view. Okay. From the 3D drawing, I do the orthographic view. This is orthographic view. As you can see in the picture, orthographic view has 3 parts. The first part is top view, side view, front view. This is the part that I do in the project. That's all from me. Thank you.
And for this project, I'm involved in sketch of conceptual design, specifically in 2D design. So here is our 2D design. So this is the assembly, and this is part by part. For assembly, we can see this is the cap of the boiling of the eggs boiler, the eggs chamber, and heating coil and eggs boiler base. So for this project, we use heating coil as to generate heat by converting electricity to heat and boil the water inside the boiler. And after that, we also design the eggs chamber like this, to make sure eggs stay in the center of the boiler, and there are LED also here to observe the temperature inside the eggs boiler. That's all from me. Thank you.
So my part is a CAD drawing. So this is my part, which is a body of the machine is, and the dimension is, the height is 150 mm, and the diameter is 140 mm. So basically the egg chamber will be inside the body. The function of this body is the material made of plastic, because the plastic has the properties of heat resistance. So it's also to withstand the amount of heat that circulates around the egg chamber to keep the temperature maintained. So it also to minimize the heat transfer due to conduction and radiation. That's all from me. Thank you.
Drawing for base is dimension 60 and 80, and I will do shaft actually to make this shape what we call base, and also use function of base actually is to support the body. Okay, and that's all from me. Thank you, sir.
Okay, today I would like to present about the cap of the boiler machine. As you can see, this boiler machine that I have created from the design department by using SolidWorks. Okay, this is all the it's a whole of this the cap of the boiler machine. Okay, for the function, this boiler machine is to prevent the heat from transfer to the outside. For the second, make a water boiler first. Okay, this is what I already done. Okay, that's all. Thank you.
So today I would like to present my part in conceptual design, which is the 3D representation and the explanation about it and what happened to the egg in the boiler. Okay, as we can see from the 3D representation, I will focus on this heating aluminium coil, which why we use the aluminium base as a heating coil. This is because it has a very high thermal conductivity, which allow heat to transfer to the water very fast. Okay, this picture I drew shows that the heat transferred to the egg reach its maximum value when the egg temperature reach the surrounding temperature, which means the boiling water. Okay, when we put the egg into the boiler, initially the egg is at uniform temperature. Okay, and then the water of temperature increases, it makes the egg white begins to thicken at 65 degrees Celsius. The egg yolk begins to thicken also at 65 degrees Celsius, and then the whole egg will set above 70 degrees Celsius. Okay, this is how the egg is set. Okay, that's all from me. Thank you.
Today I would like to present about the heating coil inside a boiler. So heating coil are tools that are used to generate heat. The function of heating coil is converting electricity to heat. Inside each egg boiler has a metal coil. Electricity energy travels through the coil, turning into heat and warming the cool water inside it. When the plug is turned on, a large electric current flows through the coil. When an electric current flows through it, it glow red hot which it radiates out in all directions. The coil has an electric resistance. The resistance turns electrical energy into heat as it passes through coil. Then the heat brings the water inside it to boiling point. So this is used to transfer heat to the egg. We will notice that the egg sit above, not in the water. So that's all from me. Thank you.
As a leader of CAD drawing, today I want to present about half-boiled egg. It's a super invention from Malaysia. An original Malaysian invention was made many years back. This product managed to cook a perfect half-boiled egg, 1 to 4 eggs actually for one cycle. Design of this product made for trap hot air from going outside is a nice system of invention. Okay, actually this is our group product drawing assembly, as you can see. Okay, that's all. Thank you.
Selection material which is product is made. So
I am from the group for design and planning, and my task is for the selection of the material. So in order to select the material, we have set a few criteria that we have to meet, such as the material should be lightweight, safe to use, easy to shape, and it is a user-friendly material. So we have go through a few of material, and then lastly we choose the polymer, which is the thermoplastic resin polycarbonate, to use for the whole part of our design, except for the heating coil. We choose that material because it was safe for user due to it is made by bisphenol A, and the melting point is between 280 degrees C to 320 degrees C. That's all. Thank you, sir.
Okay, today I would like to present about my task, mechatronic device and component selection. Okay, for my group, there are three main components that you can see. The first is laptop. So this is the main device to make the program, to save the data, result analysis during drawing the circuit and run the simulation. The next is Arduino. So this is used as a microcontroller to communicate between input signal and output to get the output of the project that is the determined of the temperature of egg. Okay, next is a thermocouple sensor used to measure the temperature of the water to boil the half-cooked egg. The temperature convert into the digital signal using Arduino. Okay, thank you. That's all.
And I am from manufacturing and mechatronic design. My task is to select the suitable components for this project to succeed, and the list of the mechatronics design and components are listed in this report, handwritten report. So the first component is Arduino Uno. It's a open source microcontroller used to communicate between input signal and output signal. The second component is the LCD display used to display the temperature of the water used to boil the half-cooked egg. And the third component is the potentiometer, which is used to control the brightness of the LCD background to display the temperature. And the last most significant component is the thermocouple sensor, which is used to measure the temperature of the water to boil the half-cooked egg. So that is all from me. Thank you for listening.
So I will show and explain about the coding using Arduino for heat transfer project. So the first one is we state the pin that we use. Okay, then this is input A4 and A5. Okay, this is the variable for Celsius and Fahrenheit. We're using Celsius and Fahrenheit, and this is for LCD. Okay, then void setup means the system is set up. Okay, so we configure the A4 and A5 as an input, and then we start the serial and start the LCD, and then we take a break for 0.005 seconds, and then void loop. Void loop is a repeated code in this thing. So the first one we show the Celsius. Okay, the Celsius, and then the second one is for Fahrenheit. Okay, then this is the LCD reading for Celsius, and this is LCD reading for Fahrenheit, and then we take a break for 0.001 seconds before the task is repeated. Thank you.
My leader is Syarif Anwar bin Yusri. Today I would like to explain about the coding we use to run the device we designed for the project. First, we need to declare about the component we use. Second is web setup. The data is to standby to make sure all the components is standby in the mode standby. And the last is about void loop, the most important in this part, in the coding part. First, analog read. Analog read is about read data from the sensor, and this line is about the voltage. The voltage we need to multiply by 5.0. The voltage output from the sensor around 0 until 1.75, and this row is the analog input. Analog input, the Arduino read from 0 until 1024. And the last line for the first row is about to convert all the data to get temperature in Celsius. Same goes in here. For this is for the Fahrenheit, and this part is about the display on the LCD, which is this is the first row and this is the second row on the LCD. That's all from me. Thank
you. Okay, my task is doing simulation for temperature detector. For simulation, I use online simulation. Is tinkercad.com. I combine the sketch, circuit, and coding from my teammate. I use Arduino with LCD and also with 2 temperature sensor. Okay. If the simulation is running, we can now view the temperature to do demonstration. Okay. For the simulation, you can learn. You can view at tinkercad.com. Okay, this is my design. Okay, for simulation. Okay. Okay, there are 2 sensor. Okay. First is temperature water and second is temperature egg. Temperature water, you can, if 57 Celsius, you can see at the LCD screen. It say 56.93 and we round off, we got a 57. Same to temperature egg, 42, you got 41.80. So round off, you can get 42 degrees Celsius. That's all for me. Thank you.
I'm from manufacturing and mechatronic design. This video is for my heat transfer project presentations. In my department, I'm for doing the research and comparisons. We have compared between the costing, sensitivities, brand, and the wattage. At the last, we have choose the thermocouple LCD with 2 sensors to detect the water and the egg temperature. We chosen it because it's cheap and it have a high sensitivities with temperatures, and the wattage usage is low. It can be save more money, the electric fees, and also it is very eco. So this video is my presentations. Thank you.
This project is a joining and assembly process. For joining, is at the joinings wire to connect system and component, which is using soldering the wires. For assembly process, it is value add process involving the part and structure from the selected material. Next, the concept of mechatronic, which is a combine the several type, which is electric, mechanical, and computer. So in this project, we have valve, temperature sensor, LED temperature, resistor, LCD display, microcontroller, solderer's breadboard. All combination of mechatronic develop reliable and versatile system. So pick up the signal from the process them to generate output signal. That's all. Thank you, Doctor.
From Group Design and Planning. On our first day planning, we had a meeting at Google Meet. On that meeting, I got the task to create the manual instruction. So basically, manual is instruction and have precaution for the users. So I will explain a bit about the manual. For the first step, plug in the cooker. Second, pour water to the marked level. Third, close the lid top. Fourth, push the trigger button down to heat the water. 5. Wait till the LED off, then open the lid. 6. Insert your egg inside the egg holder and put inside the heated water. 7. Close the lid and pull the trigger outward to open the valve. And wait for the water to empty the upper container. The last step, take out the egg holder and the egg is done half boiled. Thank you.
At the end, I can conclude that we make a wonderful job as a team, because I can see that all the students really take part during this project. Thank you.
For your time.